All right. So when it comes to systems of equations, let's start off. So we're going to solve systems of linear equations, but in particularly, we're looking at three variables, right? So we're going to solve systems of equations, systems of linear equations with three variables. Okay. All right. So let's look at a few terminology or a few concepts. So system of three equations in three variables have the same characteristics as something that is in two variables. Now we know how to deal with two variables. We got x plus y equals to 4, and we got 2x plus 3y is equal to 5. And from this, we can then find x and y. So in this case, we're dealing with x, y, and z. Let's look at the idea of an independent. What is an independent equation? So independent equations, they will have only one solution. And then you got dependent equations, and dependent equations have an infinite number of solutions. Infinite, non-ending number of solutions or possibilities. And then the next one is inconsistent. Inconsistent one has no solution. All right, so there's no solution for this. So those are the possibilities in terms of the characteristics that we're having there. So solving a system of equation in three variables involves few steps. All right, so we're going to have a few steps involved, and it's very similar to solving it in two dimensions as well, or in two variables. All right, let's have a look at the standard form first. So what is the standard form of this look like? So in standard form, we're going to have some coefficient x plus some coefficient y plus some coefficient z is equal to d. Right, a constant. So when we're doing this, what we want to do is follow a few steps. First thing we want to do is we want to remove any decimals or fractions. All right, so we're going to remove any decimals or fractions from all of these possibilities. The second thing we want to do is we want to eliminate one of the variables. We want to eliminate one of the variables and of the two equations. And this will result in a new equation with two variables, right? Resulting in a new equation with two variables. And once we've done that, we then want to solve, we want to eliminate the same variable using another one. So we're going to repeat step 2 with two different equations. And then we then use simultaneous equations to solve the new equations which come from here. We solve them simultaneously to get the two unknowns, and then we substitute the values back into the original to get the final amount. All right, so that's the idea behind it. So let's jump into a quick example of this one. Okay, so we are given the following question. Question says, solve for x, y, and z. And I'm told that x plus a quarter y plus 6z is equal to 2. This is my first equation. My second equation is 0.2 x plus minus 0.05 minus 0.3. So this one is in decimal form, plus 0.3z equals to 0.05. And 6 is equal to 6 minus y minus 6z. Okay, so first we got these three equations. We're going to grab two equations at a time, two of these equations at a time. So we're going to take equation 1 and 2, and we're going to try and eliminate it. So we want to get, firstly, remove all the fractions and then remove all of the decimals. So maybe we need to rewrite them. This last part is already removed, so we're going to rewrite this one into the form. So I'm going to multiply everything by 4 first. When I multiply everything by 4, I end up with 4x plus y plus 24z equals to 8. And then for the next one, I'm simply going to multiply the next one by 10. I could multiply it by 10 or 100. I can see this is true with 10. If I multiply it by 10, it's, yeah, it'll be 2x minus 0.5 y plus 3z equals 0.5. And then maybe multiply it by 2. So I multiplied it by 10 to go there. Now I'm going to multiply it by 2 all the way across. And so that's going to end up with an equation which is going to be 4x minus y plus 3z multiplied by 2, 6z equals to 1. Now, from these two equations, equation 1 and 2, we're going to eliminate by subtracting. And when we subtract 4x and 4x, it will disappear. This will become minus minus, which is a plus, so it will be 2y. And then 24 minus 6 is going to become 18z, and 8 minus 1 is 7. Okay, so I got 2y minus plus 18z equal 7. Now that I've got that, I can call this one equation number 4. Let's go to the next two equations now. All right. Now we're going to take those two equations and we're going to rewrite them here at the bottom. So the first one here I've rewritten. I'm going to take that equation, rewrite it again here. 4x minus y plus 6z equals 1. And this equation is already given, but I'm just going to move everything so that every part is aligned to the other part as well. So this would be 6x plus y, 6x plus y plus 6z plus 6z equals 6. If that's 6 in order, I can now eliminate, but I want to eliminate the same variable, x. At the moment, they don't have the same coefficients, which means that I have to basically multiply both of them by the same number to get them into two new equations. So I'd multiply this by, let's say I multiply this by 6 all the way across. And I multiply this one by. So this is the method of elimination. Yeah. So if I go and multiply this by, I can actually see 4 and 6 can divide into 12. So I'd rather go with 12. I'll multiply this by 3, multiply this by 2. Make sure that you multiply every single term by that as well. So this is going to be multiplying by 2 across here. This is going to be 2 times 4, which is 12x minus 3y plus 18z equals to 3. That'll be 12x plus 2y plus 12z equals to 12. Okay, so what all I've done now is I've just rewritten that. But why did I rewrite it? Because now if I subtract this, these two will eliminate. This will become minus 3 minus 2y, which is minus 5y. 18 minus 12 is 6z equals to 3 minus 12 is negative 9. And I'm going to call this one equation number 5. Now we've got an equation of y and z, equation of y and z. I'm going to take those two equations and now solve them simultaneously to get that. So if I bring that, I can use the elimination method again. So I'm going to go 2y plus 18z equals to 7. And I got negative 5y plus 6z equals to negative 9. And from here, I still have to find common coefficients and then multiply, right? So this is going to be equal to, I got 2y plus 18z equals to 7. And I've got negative 5y plus 6z is equal to negative 9. I've got to get these two coefficients the same, or those two coefficients the same. I can see this one, if I multiply this by 3, you'll end up as 18. So automatically I will go 2y plus 18z equals to 7, and negative 15y plus 18z will come to negative 27. And now I can subtract again. Now we don't have to subtract every single time. I mean, if the opposite sign, we can add it as well, but we will subtract those two. And 2 minus minus is going to be plus, yeah. And it's going to become 17, positive 17y. And minus minus is plus again. That'll be equal to 54. So the y will become 34 divided by 17 is 2. Now that I've got that y, I've just cracked it now, and I've got my y, I can now find all the others by substituting back into anyone. So let's, yeah, take the y, substitute back in there, and all right, so let's see if I got space here. I got 2 times 2 plus 18z equals 7. 2 times 2 is 4. 7 minus 4 is 3. 18z equals 3. Z equals 19. Z equals to 1 over 6. And I've got z and I've got y. I can put it into any one of my first equations to get x. And if I choose one of them, let's see, choose anyone. Let's say I choose this first equation over here. So using that, I've got x plus a quarter y plus 6z equals 2. X plus a quarter, now we said y is 2, plus 6 multiplied by z, which is 6. And that'll become x plus 1 equals 2. X equals 2 minus 1 is 1, minus a half is a half. And I've got x equals to a half now. So from this, I've got x equals to half, y equals to 2, and z equals to 1 over 6. Yeah. And now that's it. And now it's now solved it. And that's just using straightforward, normal, but gotta be careful, try not to use decimals and fractions, and then everything should work out in the end for this. Okay.